back to our class, okay? Please, we will continue our study. Okay. Sorry, just wait a minute. Okay. If you have any questions, just ask me, okay? Just tell me what's confusing you because we just quite slow, but I need you to sure up to now it's simple. But if you have any question want to not so sure, just tell me, okay? So we have learned the definition of gauge pressure. Sorry, I need to share to the definition of the gauge pressure, absolute pressure, right? And then let's say how to measure the pressure. And in reality and in engineer applications, we need to measure pressure. How to do that? Okay. Okay, so the pressure measuring devices. First, the easiest one, the mercury barometer. Okay, the mercury barometer is proposed in 1643. Okay, Torricelli demonstrated that atmospheric pressure can be measured using a mercury barometer, right? Here should be vacuum. That means the absolute pressure here should be zero. Okay, how can we do this? How can we do this? Yeah, you just first to make the tube full and then turn, right? And then you hear this, the atmospheric pressure will support the weight of the mercury column. And then we will know because here, the B point B, the pressure is almost marked is zero. Okay, so and we know PA here because it's right here. It's the same depth, same fluid. So PA should equal to P atmospheric pressure, and PA equal to PB plus the density of the mercury times the gravity times the H. H is the depth, right? And so we can use this barometer. We can tell the atmospheric pressure, the magnitude of the atmospheric pressure. Okay, so sure, we have other barometers except for the mercury barometer. And here I want to ask you one thing is if the tube diameter, yeah, sometimes I don't want to use a tube with large diameter. I just want it smaller and smaller. If the mercury, this biometer, the size of this biometer is small enough, very small. I mean, it's just maybe 5 millimeter. So is it accurate? Can it be very small? I mean, the size of the biometer, the size of the tube can be very, very small. No. Why? Why? Because never forget the surface tension force. Okay. Except for the, oh, sorry, here, if it's closed, okay, if it's closed, it's, so the surface tension force, if there is no air, we can ignore it. Okay. Okay. So except the mercury barometer, we have other barometer to include the burden gauge to measure the pressure. This mercury gauge is actually uh, is to apply to this defects, and the pointer collector is free and shows the gauge pressure because here uh, it will rotate. Okay, we point to we can read the pressure. Okay, we accept from the simplest biometer to measure the atmospheric pressure. We have other pressure measuring devices, just like the manometers. The manometers are used to measure pressure differences using liquid columns in tubes. Their working principles are any 2 points at the same elevation in a continuous liquid have the same pressure. We always say this way: same fluid, same depth, same pressure. Again, same fluid, same depth, same pressure. Just for example, here, A is the same fluid, okay? So PA will equal to the pressure PB, and for C will equal here. This is a U tube and it's collected and same fluid, and D service and C service, they have the same water level or liquid level. So PD equal to PC, and PD equal to PB plus rho GH, right? And PB here equal to, oh, here, this is B. Okay, sorry. He used, this is B, and then I use this as D. So we have PA equal to PD, right? Same fluid, same level, same depth, same pressure, and PB equal to PC, right? And so we have PB equal to PD plus rho GH. The pressure at point B or at the surface B is equal to the pressure at the surface D or point D plus the pressure due to the liquid weight, right? And similarly, for this one, we got three different liquids. Always remind yourself, same fluid, same level, same pressure. Okay, so for the yellow liquid, the density is Z1. We have Z2 density, we have density Z3. And how can we find out the pressure difference between PA and PB? Again, we have to remind ourselves, same fluid, very, very important, same fluid and collected, okay, same fluid, same level, same pressure. A, B, C, D, this is E, same level, PA equal to PE, right? And this is F. So again, this point, okay, PB equal to PF, right? And so PC here, from here, they should be equal, right? Because same fluid, yeah, collected, U2, PC equal to PD, same fluid, same level, same pressure. PC equal to PD, right? PC equal to PD And PC equal to PA equal to PE plus rho GH1, right? Or PA plus rho1 GH1 equal to PC because PC is actually equal to PE plus rho1 GH1, PE equal to PA, okay? And PE equal to, PC equal to PD, this one, okay? Same fluid, same level, same pressure. And PD is actually equal to PB plus, here, very, very important. You got two kinds of fluids. So you need to add them separately. So PB plus those three GH3 will equal to the pressure. At this level, we call G. PB plus those three GH3 is actually equal to the pressure at G point. And PG plus the liquid column, the weight of the water column of the liquid column here, rho 2 GH2 will equal to PD. Okay, here it's very important that you need to be careful here. You got two liquids, so you need to calculate the pressure separately. Okay, so this one. And from here, for this one, this is inclined manometer. Sometimes if we need to measure a small pressure difference, we need to use this inclined manometer because this inclined manometer will magnify the reading. What does it mean? Here, A is, this is free service. Here is atmospheric pressure, PA, right? And for this, we want to know the pressure difference between PB and PA, what it will be. Again, it's collected. And so same fluid, same level, same pressure. So the free service pressure should be equal to the pressure at C, service C, right? They have the same level. So actually we can say, so PC is actually equal to PA is equal, okay? And here, PC will equal to the pressure at the surface, PB, right? Plus, very, very important here, should be the vertical distance. Should be vertical distance. So should be here, should be vertical distance. So instead, PB plus rho GH should be H times sine theta. PB plus rho GH times sine theta. This is the depth, vertical depth from surface C to surface B. This one is very important, should be vertical distance, because we know from Euler equilibrium equations, the pressure increases in the direction of the body force. Only because of the body force, the pressure changes. Here, we only consider the gravity force. So the pressure only increase in Z direction or in vertical direction. So always remind yourself, here we need to add the weight of the vertical height. Okay, here should be H sine theta. Okay, that's very important. Okay, so yeah, this is often used, a multi-fluid manometer, just like here. If I want you to find out the pressure at point 1 or the pressure at the bottom of the glass, what should be? Fluid 1 we got the density Z1, or you use the specific gamma 1, Z1, Z2, Z3. What it be? P1, P1 should equal to the pressure at the free surface, the absolute pressure at point 1 will equal to P1 equal to the pressure at the free surface plus the weight due to the fluid 1, right? Should be Δ1 GH1. And then this one is the pressure at the interface between fluid 1 and fluid 2, right? And then plus Zo2 GH2 will result in the pressure at the interface of the fluid 2 and fluid 3. And finally, we plus the pressure due to the weight of fluid 3, those 3 GH3, right? Okay, this will be the absolute pressure at point 1. Can you tell me the gauge pressure at point 1? What it will be? The gauge pressure at point 1. We know the gauge pressure is actually the pressure relative to the local atmospheric pressure is actually equal to the absolute pressure minus or subtract the local atmospheric pressure. So this is actually the absolute pressure. The gauge pressure will equal to the absolute pressure minus the local atmospheric pressure. Right. So should equal to this, right? So this is the multi-fluid manometer. How about this one? Can you tell me? Can you tell me the this is the water, this is the air, and this is the air oil, this is the pressure P. Can you tell me the pressure P? This is the free surface, so this is atmospheric pressure. Can you tell me, can you calculate the air pressure? Can you calculate the air pressure? We got mercury and water here, and also oil. We got oil, water, mercury. Can you write down the pressure, the air pressure, using the H1, H2, H3, and we use it's gamma 1. We use specific gamma 1, gamma 2, oil is gamma 2, and mercury is gamma 3. We need you to find out the gauge pressure of the air. Can you try to write down the gauge pressure of the air? Okay, we need to find out this. Can you try? I will give you 2 minutes and then I will invite one student to help me figure out the air pressure. Okay. Okay, 2 minutes. You need to figure out. You need to write down by yourself, and then I will ask somebody to help me. Okay, I would like to invite a student to help me. So again, I will call you the last three digits of your ID. And if you don't respond to me, I will think you are absent, okay? So the last three digit is 113. Last three digit is 113. Are you there? The last three digit is 113. If you don't respond to me, I just regard you as absent, okay? So even you just seems online, but I will tell TA the last digit is 113. Are you there? Please tell me if you're not there. Okay, so sorry, 113. I think you are not there. Okay, so I will tell TA 113. Okay, so how about 122? The last digit is 122. I need to write down. Okay, 113.
Yes, Lausi.
Thank you. Thank you. Yeah, please tell me how to find out one. Just now I called 113, right? So 113 is not here. I need to report. Yes.
Yes.
Who are you? 113. Last digit, the ID number. Or 122. Can you tell me your ID? Are there? Can you tell me your ID? 122 or 113? 122, right? Hima, right? Okay. Are you there? Nobody? So how about 115? 115.
Hello, Miss.
Yes. Your ID?
115.
115. Okay, good. Thank you very much. So try to tell me. Yeah, 122. You are here, but why don't you reply to me? Okay, please tell me the air pressure. Use gamma 1, gamma 2, gamma 3, H1, H2, H3. The gauge pressure. Okay. You can't unmute? Let me, okay, let me do it for you. 122. Okay. Okay. I think you already. So next time, maybe I will ask you to turn on your video. Okay. Audio. Okay. Still can't. Sorry, what's happened already? Okay. It's okay now? I invited to turn on the video. Okay. Okay, so it's okay. Not okay, it's not today. But the 113 is not here. Okay. Okay. So here the gauge pressure.
Oh, now I can.
Yeah, good. Can you tell me the gauge pressure?
Okay. Can you repeat the question?
Here we got three different fluids here: water,
Okay.
oil, and mercury. And the specific are gamma 1, gamma 2, gamma 3 separately for these three fluids. And we also here we got the height is H1, H2, H3. I would like you to find out the gauge pressure of the air. The gauge pressure of the air. Yeah. Can you tell me?
Is this gamma by H1 equals to?
Yeah, maybe we can do step by step. Here,
Yeah.
we got 0.2, right? And this one, this is 1, and we got here, maybe this is 3. We got this 4.4. So maybe you can do this easier. So P will equal to, what's the relationship between P and P4? The air pressure and P4, what's the relationship between P and the pressure at 4, at point 4?
Pressure P and P4 equals, they're equal.
Yeah, P equal to P4
P4.
minus or plus?
It's minus, plus.
Minus,
Plus.
plus,
Yeah, plus.
plus
P3.
H3? I don't have H.
P3.
Which one?
P.
P. 3. And then
P. Then
this is 3. This is 3. Okay. This is 3. This is 2. 1, 2, 3, 4.
1, 2, 3. It's a
Yeah.
P4. P.
Yeah. Some of the students told me that, yeah, very good. But you should tell me. P equal to P4, P3. I just want you to tell me P and P4. P equal to P4. I just need to remind you, this is collected, right? This is collected. They are for water here. And so always remind yourself, same level, same fluid, same level, same pressure. So this is P4, right? The pressure, P4 is actually equal to the pressure here, the surface, if you can draw the horizontal line, okay? So this one maybe we call phi. Now it's much easier. Can you tell me the formula related P and P5? P and P5. Can you tell me P and P5? Yeah, this one thing you already learned this before in middle school. We just discussed this. The pressure distribution due to the gravity. P is equal to the free surface pressure plus the pressure due to the fluid weight. We know P should equal to P5 minus gamma 1 H1, right? P equal to P5 minus gamma 1 H1. Why? Because P5 equal to P plus gamma 1 H1. This is a vertical distance, right? H1 is a vertical distance to the free surface. So P plus gamma 1 H1 equal to P5. P, this is air pressure we need to find out. And P5 is the pressure at this level and this level because they are collected. It's very important, the same fluid, same level, same pressure. P5 equal to P4. Okay, so again, can you tell me the relation between P4 and P3? Can you tell me this is 4 This is 3. Can you tell me P3 and P4, how can you write down the relation? Same fluid, same level, same pressure. So these are 4, we use 4 prime. So 4, P4 and P4 prime should be what?
Equal.
Yeah, very good, equal. And so P4 prime plus how much? What should equal to P3? Should be it's specified that's equal to rho g, right? Gamma 2 H2, right? Equal to P3, right?
Mhm.
Do you follow this? Do you have any question about this? P4 prime plus gamma 2 H2 equal to P3, right? And so similarly, and this is the same fluid, this 3 prime. How about P3 prime? P3 and P3 prime, they should equal, right? P3 prime, they should equal. Same fluid, same level. Sorry. This is 3 prime. This is a 4 prime. Maybe we use 4 double prime. Okay. So what do we have? We should have P3 equal to P3 prime because same fluid, same level, same pressure. We have P4 equal to P4 prime. Yeah, same this oil, right? Equal to for double prime. Same fluid, same level, same pressure. And so P3, sorry, I use P3 prime will equal to, gauge pressure, the absolute pressure should be PA plus gamma 3 H3, right? Because we just use gauge pressure should minus PA should equal to gamma 3 H3. This is P3 prime, right? Do you have any question about this? So let's figure out. Yes. Yeah. Yes. Because they are different fruits. They are different fruits. Okay. Different fruits. Yes. One more. Yeah. Yeah. You see here we have 3 different fruits, right? But only the same fluid, same level will result in same pressure. So here, this is mercury, right? So the mercury and the mercury here, 3 prime, they will have the equal pressure. Here, because this is a form of oil. So
Is it have
sorry.
the same? Is it on the same level?
Yeah, same level. Yeah, same level. Same level means you say if you establish x coordinates, so yeah, they have the same z coordinates, same level. Okay. Or we say same depth to the free surface. Okay. Vertical distance, right? So 3 P3 equal to P3 prime. And here, same oil. And so 4 prime. Again, same level. Because if you establish the coordinate system, they should have the same z coordinate, right? And the problem with this one, if you establish the coordinate system, x direction, z direction, so in z direction, so 4 and 4 prime will have the same z coordinates, right? And same fluid, oil. So we have P3 equal to P3 prime and P4 equal to P4 prime. And this is oil. And here for this part, it's water. Water, so water here. Again, this is the double four double prime. Again, they have the same z coordinates, right? Same level, right? And so again, we have P4 prime 4 equal to P4 prime. Any question? Any question? More question? Are you okay with this one? If no question, I will continue, okay? I'll continue this one, but I will give you 10 minutes to submit this as the assignment, okay?
Can you tell me from the beginning, teacher? I'm just a little bit confused.
You mean this one?
Yeah, this one, yeah.
Maybe the first thing you need to know is the pressure distribution is P is equal to PA, the pressure at the phase surface, plus rho GH, right? This one, do you know this one?
Oh, yeah, I know.
Yeah, good. So here, for example, here, right? This is atmospheric pressure. This is 0.1. Oh, sorry, this is 1. This is 2. This is 3, right? This one, do you have any problem about this one? P1. Can you just P1 equal to, this is gamma 3 or gamma 1, gamma 2, gamma 3. Can you find out P1? The gauge pressure. I only need you to tell me the gauge pressure at the point 1. P1, first, can you calculate the P3? Can you calculate the pressure at point 3?
Pressure at point 3, height into density of water, gravity.
Yeah, P3 will equal to P atmospheric plus gamma 1 H1, right? Just use this, right? So for P3 equal to P atmosphere pressure plus gamma 1 H1. I use gamma 1 because gamma is equal to rho G, right? Right? Sorry?
Yeah.
Any question? This one? Should be no question, right? Yes. Okay. After you find out P3, how about P2?
Is the same?
Yeah, how to find P2? P2 should equal to what?
P atmosphere plus gamma 2 H2.
Oh, you P2 equal to atmospheric pressure plus gamma 2 H2? P2 should... Really? Here, P2. Yeah, P2 here is P3. P2 should equal to P3, just like you have 2 boxes, right? Just think about this. We have 3 different boxes, okay? Right? When you calculate the pressure on you, just calculate the weight on you, you need to calculate this part. This part,
we have
right?
to add the pressure.
Yeah, you need to add the pressure. Just think about we have three bucks. When you calculate the surface force, you need to calculate this weight, right? You can't just only include this part. Yeah, so the same here. So P2 equal to P3 plus gamma 2 H2, right? P2 equal to P3A plus gamma 2 H2. How about P1? P1 equal to P2 plus gamma 1. Oh, sorry. I forgot. Here, I just confused. Should be P1 equal to P2 plus gamma 3 H3, right? P2 equal to this is P1 equal to P2 plus gamma 3 H3, right?
Yeah.
Got it? Just like here, think about three boxes. Okay. Any question here? So here, so P3, P1, I mean for this one, P1 equal to this. P1 equal to P atmospheric pressure plus gamma 1 H1. This one resulting in the pressure at the interface between fluid 1 and fluid 2. That's 0.3, right? Plus gamma 2 H2. This actually is the pressure at point 2 or at the surface 2 plus gamma 3 H3, right? This is the atmospheric pressure. Oh, sorry, this is absolute pressure. If you use gauge pressure, well, equal to gamma H1 plus gamma 2 H2 plus gamma 3 H3, right? Any question? If no more question, we'll continue. No more question, we'll continue, okay? So this one is okay, right? And then how about this one? This one just is more complicated because we got three different fluids. And so we know that only same fluid, same level, same pressure. So when you want to use this one, you should be very careful. You need to check out whether it's a collected tube, it's U-tube, okay? It's U-tube because it's collected, right? So that means same level, same fluid, same pressure, okay? Same level, same fluid, same pressure. I mean, same level, just like you establish this coordinate system, they should have same z coordinates. So this is 2. So this is 2 prime. So we should have P2 equal to P2 prime, right? Any question? And so if this same level, same fluid, same pressure, and similarly for this one here, yeah, just full of oil for this, yeah, upside down U-tube, okay? So we will have this, just for example, this is 3, I use 3, and 3 prime. So we should have P3 equal to P3 prime, right? And here, this is the tube for of oil. We have P3 equal to P3 prime. For this collection is full of water, but again, we still have same level, same fluid, same pressure. So this is 3 double prime. So should also equal to P3 double prime. Any question? Do you have any question about this one? If no more question, we'll continue, okay? So here we have P2 prime, well, equal to the atmospheric pressure plus it will equal to atmospheric pressure, sorry, P atmospheric, I calculate the absolute pressure plus gamma 3 H3, right? This pressure, oh, this is 2, okay, plus gamma 2 3 H3, right? P2 prime will give you the pressure at the surface 2, and P2 will equal to P3 prime plus here this weight of the water of the oil column is gamma 2 H2, right? And P3 equal to P3 prime equal to P3. And P3 double prime will equal to P plus gamma water is gamma 1, okay? H1. So you can find the air pressure. Any question? If no more questions, so we will continue. Okay, so what do you have? The air pressure. So, sorry. So the air pressure will equal to, let's go, will equal to P atmospheric pressure plus gamma 3 H3. That's the pressure at P2 prime, also the pressure at 2 minus gamma 2 H2. That was the pressure at 3 prime. Also the pressure at 3. Also the pressure at 3 double prime. And minus gamma 1 H1. Okay, so please do this by yourself and then submit in the WeChat group, just like theoretical mechanics. Okay, you need to find the pressure at P1. Okay, the pressure at point 1. You also need to find the air pressure. Here, this is fluid 1, its density is Z1, its density is Z2, its density is Z3. And here, same, density Z1, density Z2, density Z3, okay? You need to write down the absolute pressure. At one point, also the gauge pressure. You need to find out, sorry. You need to find out P1 absolute and P1 gauge. And for this one, you need to find out P air absolute and P air gauge, okay?